Hi everyone, given that this question is said if the quantity of a radioactive material at T equals to 0 is 100 gram and Q in the bracket of 1000 equals to 80 gram, find its half-life. So given that your model is dq over dt equals to negative kq. So your variable here you can notice it will be t and q. So your story timeline is involving these two quantity, which is your time and your quantity. So we will have q in terms of time. So this quantity it will be in the unit of gram. Then we start with your differential equation. Your dE given here dq over dt is negative kq, and we can notice that in our dE we only have this variable q, we don't have t, so means this question can be solved by separable. So we rearrange the q to the left hand side, so multiply become division, and then this dt we multiply it to the right hand side become dt. Then we can integrate both sides to find out the solution. So integrate 1 over q will give us ln. So this one integrate respect to t, so it become kt plus c. To find our general solution means we need to find out what is your q in terms of t. So unlock this equation. Then the base e here will be moved to the opposite, and then everything at the right hand side become power. Then we simplify here. As we can see, power has plus means it will be exponential power of c in multiplication, so that power plus together. So simplify this EC, constant and constant, we just make it a constant A. Therefore, this is our general solution. So read again our question. So our storage timeline is when t equals to 0, it is 100 gram. So Q in terms of time, so means this one 1000 is your time, and it is 80 gram. Then find its half-life. Half-life means what is the time taken for your quantity to be half. So your quantity 100 to be half means 50 gram here. So based on the general solution we have, we substitute the initial value, means we substitute t equals to 0, q equals to 100, we find out what is our particular solution. So when e power of 0, it will be 1. So A will be 100. So second information, you can see we have two constants here, which is A and K. So we need a second information. We substitute T equals to 1000, and then Q equals to 80. So 80 equals to 100, E negative K T 1000. So we simplify to find out K. So move back, this coefficient will be 8 over 10. 8 over 10 we simplify is 4 over 5. So when we move the E back to the left hand side, it will become ln. And we find out the K. So divide this, coefficient will be negative 1 over 1000. And then ln 4 over 5. So 4 over 5 always positive. So lastly, our particular solution, where A is 100, then E negative K, so negative negative become positive times T. So finally we can answer the questions. When what is your T? When Q equals to 50. So we substitute Q equals to 50. So 1 over 2, move the E back to this fraction, it will be ln 1 over 2. 5 over 10 is 1 over 2. So to get T, this coefficient, when we move, it will become division. Then we just press calculator. Radioactive material decomposes in years.